Welcome to SysEng Quick. My name is John, and today we're going to continue work on our first Ansible project. My goal for today is to have our Fedora VM configured as a NAT router using nftables. In the last video, I felt that I had completed the refactoring of the Proxmox collection. However, I'm slightly addicted to refactoring. I always feel things can be just a little bit better. Good enough is never good enough for me. But I didn't want to put off the rest of the project any longer, so I decided to make what I thought would be just a few small tweaks. With regard to overall functionality, the changes are small, but they are significant. I think I mentioned in the initial project video that it would be nice if you could create a VM with multiple networks and disks. Since I needed a second interface to be a router, I went ahead and added support for multiple networks. Then I thought it would be nice if the VM would auto-start after you create it, so I added that. Then I noticed the Cloud Image Dest property and thought, that's a pretty bad user experience. Why should people need to know the exact path of their storage when we can pull it from the Proxmox API? So I fixed that. And that led me to the VMID property, which I made as an argument, even though it was hard-coded in some places, and the whole thing is a hack, so you shouldn't even ask for it in the first place. So I removed that. Now I was gonna stop there, but the lack of multiple disk support when there was now multiple network support felt asymmetric. So it does that now too. Surely it's the best possible collection for deploying cloud init images to a Proxmox server. Or at least that's my feeling right now. I'm sure future John will feel the need to do something different. For now, I don't want to cover any of those changes in the code. I want to continue with the project. Maybe I'll do a rundown of those changes at some point. Leave me a comment if that's something you want to see. For now, let's get started actually configuring the VM we started building. I don't even remember how long ago now. Here in VS Code, I made a few changes to the Create PV Host playbook to work with the modifications I made between episodes. We've got this new property, Global Cloud Image Storage. This is where the cloud image is stored when you download a cloud image and where it's pulled from when you deploy the VM. That's why I made the global variable for that. I did go ahead and add a global Proxmox API because we are now using the API in multiple roles. I didn't want to specify that in multiple places, so that is now a global as well. Down in here, I did rename the role from create VM to just API. So there's now a task file called create VM that creates the virtual machine. And so in here, we've got multiple disks defined. So the first disk is just the default 8 gig disk. All the default properties are there. So I specified just an empty dictionary to say just whatever the defaults are is fine. Second disk is going to be 20 gigs in size, and it is blank right now. We'll use that for the storage for our containers. That way I can put it on an LVM and grow it if it's needed later on. I didn't actually realize that Fedora put its root volume on BetterFS, so I could have just done that and had extra volumes there, but this is fine. I'm gonna go with LVM anyway. Down here we've got two network interfaces defined. Again, the first one uses all the defaults, so I'm using the first bridge and DHCP, but the second one uses a static IP to be the router and my second bridge. And then I did set the onBoot property to true to make sure that this host would always start whenever Proxmox does. Everything else is the same. Okay, we have already added our host to the inventory, but it is a new host, so let's make sure everything is still working with Ansible. We'll go to the terminal and let's run Ansible with the ping module against the proxy nodes. And yes, we get a response there, so that looks good. Let's try some shell commands. Let's ask it if I am the Ansible user. It says I am, so that looks good. let's check out the network interfaces. Do we have two of them? Yes, we do, ETH0 and ETH1. ETH0 is using DHCP for my network, and ETH1 does have that static IP. So that looks pretty good there. Let's see if it has internet connectivity. Let's give 5 pings to google.com. Yep, we got 5 pings back. Okay, so it has internet connectivity. That all looks good. Let's check on those disks. Do I have 2 of those? So I ls-l sd asterisk. We have SDA and SDB. So nothing on SDB yet, but we do at least have the disk. So it looks like our host is up and configured the way I asked it to be configured. So we should be ready to get started. Let's check one more thing. Let's see what kind of nftables rules it already has on here. If we do sudo nft list rule set, let's see what rules they have on here on Fedora by default. And it says nft command not found. Well, that makes sense. nftables is probably not installed on this cloud image. We'll have to do that. Let's make a new playbook. We'll go to the File Explorer under Playbooks. We'll make a new file, setup router.yaml. So in here, I want to make a new play, configure VM as router. The host we're going to target is the proxy host, and then I don't want to gather facts. So let's configure router by importing a role. The role we're going to import is the router role, and we'll qualify that with syseng quick.tutorial. And there we go. We'll run the router role. So down here, we'll go ahead and make that role. Let's go over to our File Explorer and make a new role called router. And we'll have some tasks and main.yaml. In our main YAML task, I'm going to include some other tasks. So I want to start off by installing nftables. And to do that, we're going to import task files. We're going to import install.yaml. So we'll go over here and make the install.yaml. And for this, we want to install nftables. We're going to use the package module to do that. The name of the package is nftables, and we need to become root to do that. Okay, that should enable us to install nftables. Let's go see if all of that works. We'll go to our command line, and we'll do Ansible playbook syseng quick.tutorial.setup_router. Yeah, that appears to work. So now if we do Ansible with proxy and use the module shell and the arguments nft list rule set, and we'll add the -- become flag, let's see if this works. Yes, we get a blank rule set because by default there are no rules in an nftables set when you first configure it. So I believe on Red Hat there is a directory that they auto load inside etc nftables. So let's do that. If we do etc nftables, what do we get over here? It says permission denied. Let's add -- become. Okay, so yeah, they've got some stuff over there. That's interesting. I wonder what all those things are that they're not using. So look at main.nft. What do we have over here? It does have some stuff over here. Okay, Google tells me that there is a file etc sysconfig nftables.conf, and this is what gets loaded by the service by default. And they have this include here that's commented out. So if we change that, it would enable main.nft. So we have some options. Either we can make our rules in etc nftables and whatever, or we could use etc sysconfig nftables.conf. I'm not sure it really matters, but let's place our files in etc nftables. We'll go ahead and uncomment that include statement. So first, we'll need to make sure that the service is started. So let's go back to our tasks, and let's say we should enable the nftables service. So let's do some more import of tasks, and we'll do service.yaml. So we'll go ahead and go over there. We'll make a new one called service.yaml, and here we will enable nftables service. We'll use the built-in service module. The name is going to be nftables. Enabled, I want to be true to start on boot. And state, I want to be started. We want to make sure this is started. So let's go check that out and see if that works. If I run the shell command and I say systemctl status nftables, it should tell me that it is disabled and it's not started. So that looks good to me. Let's go ahead and run our playbook and see if that changes. So we'll do setup of the router. It's unclear why it's hanging so long. Is it possible there was something wrong with this? I think the obvious problem, I didn't become true. So let's just go ahead and try that. Not sure why that was the error code, but okay. Let's try that one more time. There we go, that looks better. So if I run that command again, it should tell me, yes, it's loaded, it started, everything looks good. So yes, on its startup, it does nft-f of the etc sysconfig nftables.conf. Let's go ahead and make some nftables configuration files. In the module, I've gone ahead and add this file, nftables.conf, in files etc sysconfig. This is the default nftables conf from etc sysconfig with the include statement uncommented. So let's go ahead and go back to our task and we'll include a new task, configure nftables. We will do another import tasks, and here I want to do config.yaml. Now back here I want to add this task file, so we'll say config.yaml. And the first thing we're going to do here is we need to become root, and we'll have a become true, and we're going to have a block of tasks. So our first task is to configure nftables.conf. We're going to use the copy module to copy over this file into our sysconfig directory. So our source is going to be etc sysconfig nftables.conf. Our destination is /etc sysconfig nftables.conf. And we need to give it a mode property, so I'm going to use 0600 there. And I believe that's everything for nftables.conf. That should be fine. So the other thing we have are a couple of templates. I've added main.nft, which is what we're including from nftables. So if we look in here, we've got my nftables firewall policy. This isn't the NAT router, it's just the firewall so far. We'll add that in a bit. So it's a pretty simple firewall. I'm blocking most traffic, but I am allowing loopback traffic, established and related traffic from connection tracker. We're allowing ICMP echo request and SSH traffic. We allow forwarding traffic so long as it comes from the internal interface, and we allow all outbound traffic. We set up a filter of +20 for our priority because we don't want to conflict with any existing IP tables rules or Podman rules or firewall D rules. I don't think this is going to matter on our particular server, but it's fine to do anyways. Okay, let's go add this file to our server. So back in config.yaml, let's make another task, and I want to configure main.nft. We'll use the, not temp file, the template module. The source is going to be main.nft.j2. The destination is etc nftables main.nft, and the mode is 0700. Okay, I think that is all good for that. So let's go see if these files actually copy over. So they should. I think everything is set up except for I put a variable in here for our LAN interface. Let's go define a default for that. So in router, we'll make defaults main.yaml, and we're going to define our default interfaces for the router. So router interface for the LAN is going to be eth1, and router interface for the WAN is going to be eth0. Okay, now we should be able to run our playbook. So we'll do Ansible playbook, sysadmin click, tutorial, setup router. And we run that, nftables is already installed, it configures nftables, and it adds main.nft. Okay, that looks pretty good. Let's do Ansible-m shell against the proxies, and we will cat etc nftables main.nft, and we'll use the become. Okay, yeah, our rule is there. So if I say I want to do nft list rule set, oh, our rules aren't there. You know, we never actually reloaded nftables after changing our files. We're going to need to do that somehow. To make sure nftables gets restarted whenever we change one of these files, we'll use an Ansible handler. We haven't seen handlers before, but they're a way of taking action based on the outcome of another task. So what we could do here is add this notify keyword to notify the handler to restart nftables. And we could put it down here as well because either one of these files could change. But we don't have to copy this to each one of the tasks. We are in a block, and we can use the block to place notify. So that would be an easier place to put this. So now we will notify the restart nftables handler whenever either of these files changes. So let's go make that handler. Over in our File Explorer, in our router role, we'll make a new file in the handler directory, main.yaml. This is where we're going to define our handlers. And this is where we get that name from. So you need to make sure the name of your handler matches the name you put in notify. Okay, now we just have to do the service, and it's nftables, and the state is restarted. So whenever this handler is notified, we will restart nftables. And let's make sure we become root, otherwise that's not going to work. So this should go well. So now we're doing our notify. Let's try running the playbook again. If we do setup router, we install nftables, we configure it, we enable it. You know, I didn't see any changes there. Let's look at our rule set. It's still blank. So why didn't our handlers get triggered? Because it only triggers them if a task changes. We already placed these files here. They didn't change. If our configurations didn't change, there's usually no reason to do any action, right? I mean, we don't want to restart nftables all the time. We only want to do that if our files change. So let's just go ahead and remove one of the files. I'll remove etc nftables main.nft, and then we'll run it again and see what happens. So let's go ahead and run the setup router playbook again. Now configure main.nft did work, and we are running the handler restart nftables, and it says that it changed. And if that's true, let's list our rule set. Hey, there we go. That's the rule set I expected to see. Let's add our NAT rules now. We've got our NAT template, so let's go ahead and include this inside our main rules at the end. So we'll go ahead and add one of those includes. We'll do include etc nftables nat.nft. And now we'll have our nat.nft over here, and we'll template that onto the file as well. We've got our pre-routing chain, which hooks into the pre-routing filter, and our policy is accept. As I understand it, even if you don't have any rules here, you do need to define the pre-routing chain for masquerading to work. So we also have the post-routing chain, and this is going to give a priority of source NAT plus 20, and we accept any traffic here. If the output interface name is going out the WAN, we will masquerade the traffic. So if the LAN wants to go to the internet, we will allow it to do so out the WAN interface. That's how we're going to handle our NAT routing. So let's go ahead and add both these files over here. So we'll go back to config.yaml. We'll have one more thing to template. So we'll just go ahead and copy that. And we will do configure nat.nft. And that should be good over there. So we are notifying that as well. So yeah, I think all of this should work. We've changed our main thing to include that. We should have everything we need to make our NAT router. Let's go ahead and run our playbook one more time. We changed main.mt, we changed NAT, and you can see we only ran our handler one time. So no matter how many times you notify a handler, it only gets run once by default. There are ways you can run handlers more than once, but don't need to worry about that right now. It was only important to run it once for either of these changes. Let's go ahead and list that rule set now. And yes, we have the IP NAT chain as well. So we accept rules coming in the forward from ETH0, and we route them out ETH0, which is our WAN interface. Okay, so would this all work now? Well, no, there's one more thing we have to fix. To make sure we actually act as a router, we need to configure a kernel property. So if we go to the terminal and run syscontrol net IPv4 IP forward, you'll see that by default it's disabled. That is a sensible default, but we actually do want to act as a router, so we need to enable this. We can do that with the Ansible POSIX module. So let's go back into our task file and let's say configure syscontrol, and we'll do an import task for syscontrol.yaml, and we'll go ahead and make this file. So syscontrol.yaml, and here we're going to have one task, and the task is configure IP forwarding on IPv4. And we're going to do the syscontrol from ansible.posix. The name is going to be net IPv4 IP underscore forward, and the value is 1. And yes, it must be quoted. Don't forget to become root, otherwise you won't be able to make changes to this file. Let's go ahead and see what happens when I run this playbook now. Okay, that looks pretty good. If we go ahead and run our command again, yes, we do have IP forwarding enabled, and if we cat this file, etc syscontrol.conf, we should see that it is in the file, and it will survive a reboot. So this looks promising. I think my server would act as a NAT router now if I pointed some of my LXC containers to this IP. Let's try that out. Moment of truth time. Let's see if I can reconfigure one of the LXC containers to stop using the ATH proxy and start using our new Fedora proxy. So let's go to the command line and let's SSH jumping through our new proxy into 10.10.10.4, which should be our jammy LXC container. Okay, if I do IP route show, it says our default route is via 10.10.10.1. That's our ATH proxy host. So if I do sudo ping google.com, you can see we do have internet access. So let's just change the default route. We'll do sudo IP route delete default via 10.10.10.1, and we'll do sudo IP route add default via 10.10.10.54. So look at IP route now, and we do have our new default route. So if we ping 10.10.10.54, we can ping that with sudo. And let's see if our internet access still works. If we ping google.com, hey, it looks like it works. Can I prove that we're not still going through our ATH proxy? Well, we could shut it down, and that would guarantee that. So let's see how that would work. Let's SSH Ansible into ATH proxy local technoplaza.net. Okay, and we're just going to power off this right here. And now we'll go back into our 10.10.10.4 host, check the routes again, and let's ping google.com with sudo. And yeah, we still have internet access. If I go into one of my other hosts like 10.10.10.3, which I'm not sure what this is, Rocky 9. Okay, IP route is 10.10.10.1, so ping google.com. Ah, it doesn't work. because the ATH proxy host is now shut down. We only have internet access through 10.10.10.254. So all I have to do is go reconfigure those containers to use the new default route and restart them. And our new proxy is up and running. Before we go, let's go ahead and fix our inventory. We no longer need the ATH proxy host at all. I've gone ahead and turned that off. And we can replace this with proxy ATH local technoplaza.net to get our new proxy host running. So let's see if we can run with our servers. If we go to the command line, we'll do Ansible servers-mping. Fail to connect to all of the hosts. They are unreachable. I wonder why. Well, the answer is I did some fiddling with etc host inside the ATH proxy to make this hostname thing work. And I don't have that set up for our new router. Now, I could do that, or I could fix DNS, or there's a lot of possible options. One thing we could do is simply apply some host variables here. So, for instance, the arch host is 10.10.10.6. The bookworm host is 2. CentOS is, I think, 5. Jammy we know is 4. And Rocky is 3. Let's go ahead and do that. And let's try that out this way. There we go. Everything is now able to be connected to. So could we have templated the etc host file on the router? Yes, and that's an option, and maybe we'll do that in the future. But for now, this solution works just fine. Okay, we accomplished our goal of setting up a NAT router using nftables. I hope you found this video helpful. If you did, hit those like and subscribe buttons. It helps out the channel, and I appreciate it. Thanks for watching. I'll see you next time.